Alright guys, here we go again. Sorry for mess up, and I was really busy with my work yesterday and missed the yesterday question. But I will really get back to this question later on, and let's try to solve the Leetcode problem first. So the Leetcode problem is a maximum subarray sum with the length divisible by k. So we are given an array of integer that could be the positive and negative integers, and then one integer k. So we have to return the maximum sum of subarray of nums such that the size of the subarray is divisible by k. So let's try to understand the problem real quick. The question is very simple. It's given like two sentences. We need to return the maximum sum of subarray, not the count of the subarray, maximum sum of subarray, and then the size of the subarray must be divisible by k. So it's a little bit complicated one compared to the other problem. So okay, let's try to dry run the example 1. So we have like in here we got like okay, let's try to write something in here. We got like 1 and 2 in here, and then we are given by k is 1. So that means we have 3 options here. How come we have a 3 option? So to have a 3 option, we can think like, okay, this 1 is also one option, and then this 2 alone is also one option. This 1 and 2 combined is also one option. So just by saying that, what I mean like 1, 2, and 1, 2 combination is a 3. Let's go that 1 plus 2 is 3. So the maxima of the subarray nums. So we have to pretend the maximum of a subarray. So according to this, every value in here is divisible by 1. What I mean by value is a count. This count is 1, this count is 1. This is a count is also 1. But the value of each of these subarray are different. Let's call like value of this is 1. This value is 2. This value is 3. That's why we are returning the 3 from here and there. That's the reason. It looks like Amazon. Like this. Alright, joke aside. Alright, let's go for the example 2. So for the example 2, what we can see is we are given by 5 index nums. Let's try to write it down. Like -1, -2, -3, -4, -5. That was all negative integers. And then we are given like k is 5, k is 4. That means we need to find the subarray, which is size of the subarray, which is divisible by 4. If I could say here only have a 2 option, how can we simply know that? So since the array size is 5, let's say if it is 8, there could be the different situation. Like if it is 8, there could be the like 2 case. Size can be the 4 or size can be the 8. So since it is a 4, we have 2 options. From index 0 to index 3 is a 1 option. Another one is index 1 to index 3. Index 4. 1, 2, 3, 4. Yeah, index 1, index 4 is another option. So how can we find the value for this? Let's consider like -1 and -2, -3, -4. So total of these values will be 1 plus 2 is 3, plus 3 is 6, 6 plus 4 is 10, -10. And then I'm gonna repeat this again in here. In here, so that will be from -2 to -5. So since we are comparing here, so 2 plus 3 is 5, 5 plus 4 is 9, 9 plus 5 is 14. So we are comparing the two values in here, which are the -10 and -4. So according to the mathematics, the less in minus is the maximum sum. So since -10 is definitely larger than the -14, that is the reason why we are returning the -10 here. Alright, so let's go through the example 3. So for example 3, there's so many possible options available, and it is also the great option and a great XML to consider as. So let's try to write down what are the possible arrays in here. -5, 1, 2, -3, and 4. So I will say there's so many possibilities can happen. Since divisible number is a k is a 2, so let's call like k is 2. So we can have a subarray like 2 items of subarray or 4 items of subarray, since 4 is also divisible by 2, which is like any multiplication of 2 could be the subarray size in here. So how can we find it? We have many possibilities. Let's start from the something like here, -5 and 1, this is one option. 1 to 2, that's also another option. 2 to 3, that is also another option. And then 3 to 4, that is also another option. Okay, let's try to write down this possibility first. Later we will forget. So let's call like -1, -5, and 1. So that will be 4. And then 1 and 2. That will be, let me make the values in the same order. Let's call it 3. And then 2 and -3, which should be -1. And then -3 and 4, that will be 1. Alright, and then we have other possibilities that could happen in here also. So let me try to provide and show you guys in the different color. Since it is a k is 2, we can have like subarray of 4, which is divisible by 2 also. So since it is represent in the blue color, I will write down here -5, 1, 2, -3. That is a one subarray. So how do we find it? So -5 and -3 combination of -8, and then deduct the, so that would be the, deduct the 3 will be -5. So we can simply say like 1 and 2 and here is totally equivalent to the -3 in here. So we got the -5 as a final result. So next is a 1, 2, -3, and 4. How do we do? Similar approach. 1 and 2 is 3 in here, -3 and 3 will become the 0, and 4 is the answer in here. Alright, so we got like 2, 4 in here. So we can simply return any of the 4, which is the result in here. Yeah, and then that is the reason why output is 4 in here. Yep, and then yeah, we have to return the measurement sum of the subarray. That is yeah, I think in here we also notice that we are choosing the largest number of the subarray. So that is literally the how the question works. So to explain that, let me try to write the code and try to explain along the way when I was writing the code. Let's call like n will be the count for the nums, and then we will have like prefix sum. So pretty sure like if you see like this kind of question, that is for dynamic programming for sure. Right, let's see the hint. Yeah, even though it's not say dynamic programming, that's definitely the dynamic programming related question. So okay, let's try to keep these two examine in here. Wait, where is my examine goes? Okay, and then we will keep the prefix sum as a 0, and then for the reset we're gonna keep like dot minimum So in here, there's a one drawback. So we can regard like there's always the answer is always in the problem, because there's no criteria like if we're gonna find the valid maximum subarray of sum with the large divisible by k, what is the number we don't need to pretend, we don't know. So maybe we can just pretend 0 at the moment since we just want to write the code first. So I want to keep track of the minimum and maximum prefix sum of the each modulo group. Let's call like minimum prefix, which will be the dictionary for sure. So we're going to keep track of keys and value. The same for the maximum prefix. We'll keep track of the keys and values in here. And then for initially, what I want to do is I want to put the 0 for the each prefix. Let's call like minimum prefix of 0 will be the 0. Same for the maximum prefix of 0 will be the 0. And then what we're going to do is we're going to iterate through all the nums given here. So we're going through like 0 to the less than n, since we are 0 index array and we don't want to go like index out of bounds. So that's the reason why we're using the less than n, which is the names of the count. And then we keep updating our prefix sum by using the nums of index. So that's technically mean like every time we run through, we keep updating the prefix sum. So if I have to show the result in here, it's so for the prefix sum for the HTML1 will be 3. This one will be 6, 10, 15. This one will be -1. So let's try to run and see how. So we're expecting 3, 15, and -1. So here got 3, definitely what we want. And then 15, -15, definitely what we want for HTML2. And then -1. So which is just the addition of all the numbers in the given arrays. And then what are we going to do next is we're going to keep the mod. What I mean by mod is like I'm going to mob the index. You guys may have a question why I mob the index instead of the prefix sum. So bear with me and come along with me and I will explain you in the later on. So since it is like mobbing the index of 1, not index of index plus 1, that means we are forcing the each values what is happening outside. What I want to do is if we just want to separate what are the position possible for X, we can keep in our minimum prefix and maximum prefix. Let's call like minimum prefix. Let's call like previous number. What I want to do is I will search a minimum prefix by using our mod. So the understanding of the mob, every time we run the array iteration in here, I'm gonna print out the mod for you guys to see. But it doesn't make sense in the HTML1. It will much more make sense in HTML2 and HTML3. I just want to categorize the possibility between the numbers. So in here, for the HTML1, I got like 0, 0, since we have only 2 indexes in here, which is a 0 index and 1 index. So 0 plus 1 is 1, 1 is divided by 1. So that is a mod is a 0. That's for sure, we got 0. The same, next iteration. So 2 is 1 is also divided by 1. Yeah, that's the case. So we move to the next HTML2. So that's a very good HTML to explain to you guys. So we got a mod. And then in index 0, we start from 1. And then 1 is divisible by k is 4. So we got the 1, which is our index. 2 2 still not divisible by our k value. The same 3 is not divisible, but the 4 is divisible in here. So that's why we got the 0 index, and then we see the 1 again. So by doing that, we are categorizing that what are the possibility group we can see in each index. So let's move on to the next index. So if we move to the next one, so it will be the different opportunities for us. Since k is 2, so we are dividing like start from 1. So I would say here we start from 1 to 0, 1, 2, 3, 4, 1 to 4, 1 to 5. Since we have 0 in the space and total is a 5 number, since we plus 1 to here, and then like 0, 1, 2, 3, 4. But that's why it's going from 1 to 5, and then 1 to 5 will be modulo by k, which is 2. So let's go with the 1. So 1 mod by 2, we have a remainder of 1 for sure. So 2. So we got the 1 group. Since 2 is divisible by 2, which we get the remainder of 0. Then 3. 3 is not divisible by 2 for sure. Then we got the modulo of remainder of 1. So we got the 2 1 group in here already. Next is 4. 4 is divisible by 2. So we got another 0 group. So we got 2 0 group and 3 1 group in here. That is what I'm doing. And then in here, what I'm going to do is I'm going to search the mob is already exists in our dictionary or not. If we have, I'm going to update the result by checking the match between the result and prefix sum. So detect the minimum previous. So why I want to detect the minimum previous from result? So minimum of 0 mean if I have to print out the values for you guys in here, let's show what is the value of result at initially. That will be literally a very tiny value in the Swift integer, which is minus like negative 9 billion or trillion, I don't know how to pronounce it. It's like very negative and very minus values. It's a very minimum values integer of the Swift. So we're comparing the result, the initial result with the prefix sum. So okay, let's write the code first. I will do the dry run later on. Let's call like mass prefix previous, and then I will find the mass prefix of mod, and then updating the result in here also. So what I want to do is find the mass result and prefix sum, detect the mass previous. Alright, so at the end I need to update my mod also in the for loop. Let's call like minimum prefix of mod will be the minimum prefix of mod n. So we could say minimum prefix of mod could be the negative. Let's call integer.max, and then with the prefix sum, and then the same for the maximum of prefix sum, and then let's mod it. So this time we're taking the max in here from the maximum of prefix mod, and if we have like no values in our dictionary, we will take the minimum in here with the prefix sum. So alright, before I go through it, let's do the dry run for each XML so that we have a clear understanding of what I'm doing here. So let's go for the XML1. So for go through the XML1, we have like count of 2. The previous thing is minus for sure, and then we will have like dictionary in the near future like this initially, and everything is 0. That means like we have initially like 0 is equal to 0 in here, 0 is equal to 0, and then what I want to do is we have 0 and 1. And then I'm gonna iteration through the prefix sum. So to update that, what I want to do is the prefix sum originally the 0, and then 0 plus 1 will become the 1. Next, I will do the mods to the 1 to 2, and then k is 1 here. So 0 plus 1 is a 1, and 1 modulo by k is 1 here, become the 0. So we got the mod is 0 now. Let's consider the mod is 0. And then I'm going to find the value of mob in here. So since we don't have any values, so we don't need to do anything. The same for the mass. We don't have any. Okay, we have a value, sorry. So since we have a 0 in here, so if we have a 0, what I'm going to do is I'm going to update the reset. We're going to take a massive band initially. So the result is a very minus negative. And then we have a prefix sum. Now our prefix sum is a 1 minus minimum previous, which is a 0. So we can say like 1 minus 0, which is a 1. So we take the reset and then begin the 1. And then we go to the mass previous. So mass previous originally also the 0. Yep, also the 0. And then we are going to check like the reset. Now our reset began the 1. And then our prefix sum is also 1. 1 minus the mass previous. So which is 0. Something like this. 1 minus previous is, yeah. So that will be like choosing between the 1 and 1. So the result is still the 1. So next, I am going to update the mod in here. So which is like minimum prefix of 0. So mob is in here is a 0 at the moment. Since 1 modulo by 1 is 0. And then we are going to compare the minimum, which is we have values initially, which is 0. Yeah, 0s compared to our prefix sum is 1. So we take in the updating the 0 with the 1 in here. The same next approach, maximum prefix, we're going to check, which is 0, also the 0 in here. So we're comparing 0 with the 1. So we're going to take in the mass in here, which is become 1. Yeah, so in comparison in here, like well, if we can find the minimum prefix of 0 mob, which is a 0 in here, and then our prefix sum is a 1 in here. Okay, so we're taking the minimum like 0. So our first iteration, we are expecting like 0, 0 and 0, 1 for the minimum prefix and maximum prefix. That will be the maximum. Okay, I am having a separator for us to easy to understand. Let's try to dry run. Okay, so do we get what we expect? Yes. And then next, we're going to run again. So this time, our index began the 1. And then 1 plus 1 divided by k. So which will be like this. 2 mod by k is also 0. So we are still checking, is 0 already exists or not? Yes, we have. And then we are checking our reset, which is 1 in here. And then our prefix sum will become 3 in that case, because we have updated in here. So I'll update to the 3. So what we are doing is 3 minus our previous value, which is 0. Like this. Our reset at the moment is 1. So our prefix sum is 3 minus our previous is 0. So we are taking like between 1 and 3. What are we going to take? We're going to take the 3 for sure. Then our result began 3. So that is one case. So we check the maximum previous of the mob 0. So we have result is now 3 in here. Our previous sum is 3. 3 minus our max previous. Max previous of 0 is 1. So we are taking between like 3 and 2. So what it will happen is 3 for sure because we are taking the max in here. And then I'm still updating the mod. Since mod is 0, it will begin like minimum previous of mod, which is 0 in here. So we are comparing like minimum of 0 and previous sum, which is 3 in here. So what do we take? We take the minimum. So our minimum previous of here will still the 0, and then we will take the max in here. So our max of value is 1 here, our previous sum is 3, so we take the 3 in here. So this will become the 3. So that is why you guys see like 0, 0, 0, 3 in the next step. And then at the end, how do we find the result? So if our result is equal to the minimum, because we set the default value as minimum in here. Okay, I will show it off. How about we just return the result and try to run it. Let's see we got the problem or not. Yep, and then trying to submit. I think it will have some issue because there could be the case we are having an issue with the. Alright, we got the time limit AC. I mean, like not the time limit, is upper limit AC. So we need to summarize the answer. If it is compared to the minimum, we return the 0. If not, we just return the result. Let's try to submit that. Oh wait, I think I did something wrong in here. What did I do wrong? Okay, this is my problem. I should not be printing a lot in here. Okay, let's try to submit with just a result. Let's see it's work or not. Yep, I think the time complexity will be the O of n, since we just iteration through from 0 to the end of the array. Then the space complexity will be the O of k, because it is mostly dependent on the k. But I still want to do more dry run for example 2 and example 3 for you guys to much understand. If not, you guys still don't know what is happening here. So for example 2, we have a count of 5 in here, and then we have represent initially 0, this one 0, this will begin at 0. So what are we doing here? So we are doing from 0 through the 5. So technically like 0 to 1 to 4. Yeah, that's what we are doing. And then yeah, same, updating the previous sum. So to update the previous sum, we have initially the 0, 0 plus 1, which will begin the -1 here. And then we calculating the mod in here. So the same for the mod. So we are modding with the k values of 4. And then we initially have a 0, 0 mod by k, which is 4 in here. So that will be the 0 plus 1 is 1. That will be the mod of 1. So now we have a mod of 1, and then we're going to check our previous mod of 1 is already in there or not. Since it is not there, we don't need to do anything. Then we're going to update it. So in here, what I'm doing is I'm finding our minimum previous of mob. Mob 1 is doesn't exist. So I'm comparing like maths and our previous sum. What is our previous sum in that case? It's a -1. Yep. So we want to take the minimum, which is the last value. So you're comparing the max and minimum. So we are setting the -1 in here. So mod is 1, and then -1 is the value. Same in here. So we have a mob of 1 now, and then we are comparing like initial of mob of 1 doesn't exist, so we have comparing like minimum in here, and our previous sum is a -1. So we want the max. What do we got? We got the minimum for sure, so it will be like this. I'm gonna print out in here for you guys. Let's call like minimum prefix, and that will be the maximum prefix. Let's try and run it out. Yeah, that is what we expecting initially. Oh, I forgot to put the bracket for you guys. So for the first step, we should be expecting like okay, here that is what we expecting. 0 zeros, 1 -1, and then 0 0 and 1 is to minimum. That should be the -1. Oh yeah, here we are taking the minimum. So if you guys want to know, I can print the what is the values in here. Yep. Let's print it out for make sense. Let's call like mod is a 1 does exist. So we are comparing between like int dot minimum. Let's try and run it. Wait, and then there is something wrong. Oh yeah, we are setting the maximum prefix in here. So yeah, that is the reason why we are receiving the -1 here. Since we have like negative, we are comparing like negative 9 something with the -1. That is the reason why we are receiving the -1 here. So I'm gonna update like -1. Right. And then next step is where it become the index of, okay, where we began 1 here. So we stay updating our previous sum, which is a -1 and -2. So that will begin -3. That is what we expected. And then index begin 1, 1 plus 1 is 2. 2 is not divisible by 4. So we got the mod of 2. Since the mod of 2 does exist, we don't need to do anything of here. Yeah, and then we arrive to here. So we want to update our mod of 2 is comparing here. So since the mod of 2 does exist here, we have like plus mass plus our previous sum. What is our previous sum in our case? Now it's a -3. So we want the minimum. So yeah, so it will begin like this. Let me update for here. So that will be the mob is 2 in here, and then our value is minimum, which is -3. Next step, our mob prefix is 2, and then we are comparing like a mod of 2, which doesn't exist. Yes, that will be the minus minimum, and our previous sum, which is -3. We want to take the max, that is a -3. So that is what our ideal values we expected for here. So we got like 0 0 0 0, which is the same in here. So 1 -1 1 -1 also in here. 2 -3 2 -3. That is what we expected. And then we are going to the next iteration, which is 2 in here. So 2 plus 1 became 3. So we have become more of 3. And then since more of 3 doesn't exist, we don't need to do anything for this approach. And then we want to compare it here again. So we have like plus mass, and our previous sum need to update. So since it is index 2, so we are going to be the +6 for the previous sum. So we are comparing like -6 and then the -6. Yeah, so we need to update. Our mob is now become like 3. Key is a 3, and then we want the minimum in here. So minimum is a -6. Same. 3. Our minimum also the same, -6. So that is what we expected. And then let's check it out. Yep, exactly same. 3 is to -6. Since it's dictionary, the order may be different. And then we go to the next iteration, which is index 3. We're almost there, bear with me. And then what I'm receiving here, I'm going to update the iteration also, since 0, 1, 2, 3, so which is 6 plus 4 is become the -10. And then 3 plus 1 become the 4. And first in our iteration, our modification of the modulo of 4 will become the 0. And then we have these value already exist in our dictionary. That is what exactly we want to do in here. So we are going to compare like our reset, which is minimum at the moment, mean like minus minimum, and then our previous one -10 minus our minimum previous is 0. So we are comparing between like minus minimum and -10. And definitely sure we take the -10. So we are going to update the reset with the -10 in here. So now our result is become -10. And then next step, we checked our maximum previous. So since we have like initial value zeros in here, and then our result is -10 here, and then our max prefixation is also -10, and our max previous is 0. So we are comparing like between like -10 and -10. That is definitely sure it's a -10. So the result stay the -10 in here. So we are going to update all the mobs in here. So our mob of 0 is already exit, which is a 0 in here. And then here also will begin the 0. And our prefixation is a -10 already. And here also -10. So what we are going to update here, we are going to take in the minimum since 0 and -10. So -10 begin the minimum. The same, we're taking the max in here, so it will keep the 0 for sure. So we now in the index of 3, like 0, 1, 2, 3. So dictionary of the minimum prefix 0 is a -10 here, so it's 0 is still keep the 0. That's what we want. Let's go through our one last iteration. I'm sure you guys will be boring for that. Then 4 plus 1 become the 5. Then we get the mod 1, which is already exists in our array, our dictionary. And then we can find like 1 is here, is a -1. So we compare like reset. Reset is now -10. And our prefixation need to update also. Since it's the prefixation begin the -15, since we update in here. And then we are doing like -15 minus our minimum previous. Our minimum previous of the minimum previous is -1. So -1. So that will begin like -14. So we want the max, which is stay the 10. The same, we go to the next step. So our maximum prefix of 1 is a -1. So -1 here. And then we have a reset, which is a -10, our prefixation -15, and our max previous, which is -1. So 15 minus -1 will become the 14, -14. So we still want the maxima. So one comparison between -14 and -10, we still choose the -10, since the result is also 10 here. So but we still need to update the dictionary just to have our clue between ourselves. So mob of 1, which is -1 here. Okay, let me update this with the -1 and -10. And then the same, our max prefix of 1 is -1 here and -10. Since we want the minimum in here, so minimum between -1 and -10, pretty sure it is -1. So we update the 1 with -1 since we don't update. The same, we want the, wait, that would be the -10. Okay, So choosing between like -1 and -10. So -10 is younger than the -1 for sure. So we have to update the 1 with the -10. And then in here, we choosing the -1. So 1 is will become the -1. And then let's check our final result over here. So 3 is -6, which is correct. 0 is -10, absolutely correct. And the 1 is a -15. Alright, we need to update in here. So our begin the our previous began -15. That's my bad. So since we want to update between the middleman, these two -15. So one of this will become the -15. Then let's double check. Yep, that's -15. 2 is -3. It's correct. 0 is still 0. 3 is a -6 in here, correct. 1 is -1, correct. 2 is -3. And then at the end, we got our result, what we want. Yep, that's all for it. And I will let you guys run the dry run for example 3 and let me know if you don't clear for my solution. And once again, my time complexity of O n, and then my split complexity will be the O of k. Yeah, that's all for it, and see you in the next video. Bye.